In this video lecture, we'll study about empirical and molecular formulas. First of all, we must understand what is the meaning of formula. Formula is the symbolic representation of an element, of a compound, or an ion. So, symbolic representation of any substance is called as formula. Formula tells us about various type of elements, that is qualitative information, and amount of various type of elements present in given molecule, that is quantitative information. So we can say a formula tells us about type of various elements present in given molecule as well as their amount. Formula is of mainly two types. One is molecular formula, another is empirical formula, or it is also called as simplest formula. Molecular formula tells us about actual number of atoms present in a molecule. It tells us about actual number of atoms. Empirical formula tells us about simple ratio between different atoms present in a molecule. So empirical formula simply tells us about the ratio between different atoms in a molecule, and molecular formula tells us about actual number of atoms present in a molecule. For example, let's take the example of benzene. Its molecular formula is C6H6. That is, it tells us how many number of atoms are actually present in one molecule of benzene, that is 6 carbon and 6 hydrogen, and its empirical formula is CH, means simplest ratio. So empirical formula tells us simplest ratio. Another example is ethyne, molecular formula C2H2, empirical formula CH. Similarly, glucose as well as acetic acid. So now we can say molecular formula tells us actual number of atoms in one molecule, and empirical formula tells us about simplest ratio of different atoms. Out of molecular formula and empirical formula, molecular formula is always preferred because it tells us about actual number of atoms. Further, two or more molecules can have similar empirical formula, as we can see benzene and ethyne. They are differentiated by their molecular formula, but their empirical formula is same. Similarly, for glucose and acetic acid, we cannot differentiate between these two species by their empirical formula because that is same, but their molecular formula are different. So molecular formula is preferable over empirical formula. But for molecular formula, we must understand how to find out empirical formula. So now student, try to understand how to write empirical formula. Now let's take one example. A compound consists of carbon 40%, hydrogen 6.66%. We need to find out its empirical formula. So the first step is to understand the given format of a table. The first column is serial number, then symbol, then percentage of elements, then atomic masses of elements, then relative number of moles, which is equal to percentage divided by atomic mass, then simple ratio, and in the last, simplest whole number ratio. So now, put the given values in this table format. So we are given carbon 40% and hydrogen 6.66%. So serial number 1 and 2, elements carbon, hydrogen, their percentage. Now at this step, just try to understand what is the sum of percentage. If the sum of percentage is 100, then we can proceed further. And if the sum of percentage is less than 100, it means there is another element which is always oxygen, and rest of the remaining percentage will be of that of oxygen. So here we can say the given percentage are 40 plus 6.66. Hence, the sum is 46.66%, means less than 100. It means there will be a third element, and that is always oxygen, and remaining percentage means 100 minus 46.66, and that is 53.34% will be oxygen. So this is the most important point while finding out the empirical formula. A student should know about the sum of the percentage of all the given elements. Now the next column, in this we need to put the value of atomic masses, 12 for carbon, 1 for hydrogen, and 16 for oxygen. Now the next column, relative number of moles, which can be calculated as percentage divided by atomic mass. So for carbon, the percentage is 40 and atomic mass is 12, hence 40 by 12. For hydrogen, 6.66 divided by 1. For oxygen, 53.34 divided by 16. And the relative number of moles are 3.33, 6.66 and 3.33. The next step is to find out simple ratio. So divide all the values by the lowest quantity. As we are seeing, in relative number of mole, the lowest quantity is 3. So we can say it is 3.33. So divide all the quantities by 3.33. So the simple ratio is 1 to 1. Now simplest whole number ratio. We find out simplest whole number ratio only when the simple ratio is in fraction. Now in this case it is not in fraction, so it is the simplest whole number ratio. So we can say carbon 1, hydrogen 2 and oxygen 1. So the empirical formula is C1H2O1, and empirical formula mass will be 30 AMU. 12 plus 1 into 2 for hydrogen plus 16 into 1 for oxygen. So by this method we can find out empirical formula. So after empirical formula, now let's understand how to find out molecular formula. molecular formula is equal to N into empirical formula. So if we know empirical formula, only then we can get molecular formula. The value of N here is, it is equal to molecular mass upon empirical formula mass. So if we put the value of N in above equation, our new equation will be molecular formula is equal to molecular mass divided by empirical formula mass into empirical formula. We also know molecular mass is equal to 2 into vapor density. So if we put the value of molecular mass in above equation, we have new formula, that is molecular formula is equal to 2 into vapor density into empirical formula upon empirical formula mass. So in numerical, if you are provided with molecular mass, then use this formula, and if in the numerical statement you have vapor density, then use second formula. So you have to use only these two formulas, one in terms of molecular mass, another is in terms of vapor density. So this is how we can calculate molecular formula from empirical formula. Also try these two questions yourself. Question number 1. Write the relation between molecular formula and empirical formula mass. And question number 2. Write the relation between molecular formula and vapor density. So now let's use the term molecular formula. How can we find out molecular formula? In this question we can see that empirical formula is given C1H2O1 and the molecular mass is 180 AMU. We have to find out molecular formula. So empirical formula is C1H2O1. Empirical formula mass will be 30 AMU and molecular mass from the statement 180 AMU. So the statement possesses the value of molecular mass, hence we'll use the formula molecular formula is equal to molecular mass into empirical formula divided by empirical formula mass. So after putting the value, we'll get our answer as molecular mass is 180, empirical formula mass is 30, and in the empirical formula is C1H2O1. And after solving, the answer is molecular formula is equal to 6 into empirical formula, that is C1H2O1. Hence our final answer is molecular formula is equal to C6H12O6. C6H12O6. Now let's take another example. So the question is percentage of carbon, percentage of hydrogen. We need to find out empirical as well as molecular formula, and the molecular mass is 180. So the same method, same table format. First of all, put the value for empirical formula, the symbol of elements, their percentage, then check the sum of percentage. It is below 100, it means third element, that is oxygen, and remaining percentage is of oxygen. Their atomic masses, relative number of moles, percentage divided by atomic masses, and simple ratio, divide the lowest value or divide from the lowest value, and the simple ratio is 1 to 1. Simplest whole number ratio will be same. So empirical formula will be C1H2O1 and empirical formula mass is 30. Since in the statement molecular mass is given, so for molecular formula use the formula of molecular mass. Molecular formula is equal to molecular mass into empirical formula divided by empirical formula mass. After putting the values, you get answer C6H12O6. So students, this is the method how to find out molecular formula and empirical formula. Now I am just going to tell you another method for molecular formula. For this formula, we use another formula to calculate number of atoms by percentage. The formula is percentage of element into molecular mass of compound divided by 100 and atomic mass of elements. If we use this formula carefully, you'll get answer easily directly for molecular formula without calculating empirical formula. Now let's check through one example. Example is same which we used in previous method. So we can understand the sum of percentage is below 100. It means there is third element, that is oxygen, and its percentage will be 53.34. First of all, find out number of carbon atom. Use the above formula, that is percentage of element into molecular mass divide by 100 and atomic mass. So 40 is the percentage of carbon, 180 is the molecular mass given in the statement, and 12 is the atomic mass of carbon. After solving, the number of carbon atoms are 6. Similarly, we can find out number of hydrogen atom. Use the same formula. The percentage is 6.66 into 180, that is molecular mass, divide by 100 and 1. 1 is the atomic mass of hydrogen, and the number of hydrogen atoms are approximately 12. The number of oxygen atoms by same formula are 6. So in this manner we can get carbon 6, hydrogen 12 and oxygen 6. Hence the molecular formula is C6H12O6. So students, we can say it is also an easy method. Without solving empirical formula, we can directly solve molecular formula. You can solve the another example. In this, we can say the percentage of carbon, percentage of hydrogen and percentage of oxygen along with molecular mass 60. we need to calculate molecular formula. Now it will be very easy to use for you. Number of carbon atom. So as you can see, the percentage of carbon is 39.9, atomic mass 12, molecular mass 60. Hence the number will be 2 for hydrogen atom. The percentage is 6.69, atomic mass 1, and the number will be 4. For oxygen atom, after putting the value, the number is 2. So we can say the number of atoms are with us. Hence the molecular formula is C2H4O2. So these are the methods how to find out molecular formula and empirical formula. Try to solve following. These are few important questions for your examinations. Solve them very carefully.